That includes syllabus of NetJRF, GATE, JEST, and TIFR. So we can broadly classify this topic in three parts. So that will be electrostatics, in which we will talk about static electric field due to stationary charges. Then we have magnetostatics. We will talk about static magnetic field. So that is magnetic field due to steady current. So these electrostatics and magnetostatics covers the static part. And third is the time varying field, general when E and B is function of time. So we call these fields as time varying fields. Time varying fields. So that is the broad category of electromagnetic theory. So let us see what we will study different topics in electrostatics, magnetostatics, and then in time varying field. So first one is electrostatics. Please note down the syllabus. We will talk about field due to stationary charges. Field due to stationary charges. So in electrostatics, we will focus on three parameters. One is charge. In general, let us represent it by charge density. Then you must know electric field, and you must know what is the electrostatic potential. This is the stationary charge. In this case, I have taken charge density. In general, that is the charge density. So you will see in electrostatics, when stationary charge is given, we have to find electric field. Charge is given, you can find electrostatic potential. E is given, you can find charge density. V is given, you can find charge density. V is given, you can find electric field, and E is given, you can find potential. If you know these relationship, you know about electrostatics. That is all about electrostatic if you can relate these parameters. Stationary charge is given, how to find electric field and potential, and then relate these parameters. So how to relate these parameters? First, we have to see when stationary charge is given, how to find electric field. So that will be our first topic of electrostatics. When stationary charge is given, how to find electric field. So you all know we use Coulomb's law. So first topic in electrostatics will be Coulomb's law and superposition principle. This is the first topic of electrostatics, Coulomb's law and superposition principle. So we will talk about Coulomb's law and superposition principle. Then you will see that we have certain symmetry, like if you have dielectric sphere or dielectric cylinder, we can simplify our calculation using Coulomb's law, using Gauss law. In Coulomb's law, you can find in certain symmetry, but using Gauss law, we can further simplify our calculation in three symmetry, especially spherical, cylindrical, and planar symmetry. So whenever symmetrical charge distribution is given and you have to find electric field, we will use Gauss law. So we will talk about Gauss law and its applications. In Gauss law, we will discuss about electric flux also. So using the concept of flux, we will see Gauss law and then we will apply it in symmetrical charge distribution. Then we will talk about, if you know electric field, we can define potential. So how to find electrostatic potential in different configuration. So next topic will be electrostatic potential. Electrostatic potential. You will see when potential is given and you have to find charge density, we can use Poisson's equation. So we will also talk about Poisson's equation and Laplace equation. Then we will see how to calculate electrostatic energy of the configuration. We have electrostatic energy. Electrostatic energy of the configuration. Now we will discuss two types of material. One is dielectric, another is conductor. So initially we will talk about only dielectric material, dielectric or insulators. Then we will separately discuss conductors. What are the properties of conductors? So next topic will be properties of conductors. Properties of conductors. Then we will talk about electric dipoles. What are the electric dipoles? You will see in electric dipoles, we will find potential and electric field. And then we will see what will happen when dipole is placed in an external field. It will experience torque and force, whether field is uniform or non-uniform. We will also talk about potential energy of the dipole and interaction energy of the dipole. So there are different subtopics in each topic. So like next one is, if you know electric dipoles, after that we will talk about polarization. You will see when a dielectric is placed in an external field, it gets polarized, and we will define polarization P. So we will talk about concept of bound charges. Concept of bound charges. So when you have polarized dielectric, then we will see what will be electric field in a polarized dielectric. So we have to modify the Gauss law. So we will discuss Gauss law in presence of polarized dielectrics. You will see in Coulomb's law and Gauss law, we will express electric field in terms of E vector. But here we will express in terms of D vector, and you will see D is epsilon E. We will discuss these relationships. So we will talk about initially that is unpolarized, and when it is polarized, then we will express in terms of D vector. And then we will see electrostatic boundary condition. What will be behavior of external field at any boundary, whether you have dielectric or dielectric conductor. So we will talk about electrostatic boundary condition. Electrostatic boundary conditions. So you will see boundary condition for E, D, E and V. Now, lastly, we have two separate topics in electrostatics. One is multipole expansion and another is image problem. So that we will discuss separately. So next we have multipole expansion. So what you will calculate in multipole expansion? You will see in Coulomb's law and Gauss law, in certain symmetry only you can calculate potential or electric field. First electric field, then potential. But when you have some arbitrary charge distribution, how to find electric field and potential? And for that case, we will use multipole expansion. So since distribution is arbitrary, so in multipole expansion, you will get approximate V or E. So we will talk about approximate potential or electric field due to any arbitrary charge distribution. Charge distribution at large distance. At large distance from the charge configuration. Far away from the charge distribution, you will get approximate potential and electric field. So when you have symmetrical charge distribution, you can use in certain symmetry Coulomb's law, in three particular symmetry Gauss law, and when you have arbitrary charge distribution, you can use multipole expansion. And lastly, we will discuss image problem. Image problem. So these are the topics in electrostatics that we have to focus. Is it clear? Please remember these topics. You have to remember the syllabus, what topics you are going to study. And I will ask you in each class what topic you have studied and what is the next topic that you are going to study. So if you remember the syllabus, then you can answer. Is it clear?
Yes, sir.
Now you have one separate chapter that is related to both electrostatic as well as magnetostatics. So first I will complete that chapter and then we will talk about magnetostatic. And what is that chapter? You have a separate chapter that is motion of charged particles in in electric field in magnetic field. And you will see when both E and B is present in electric and magnetic field. So this is the separate chapter, motion of charged particles in electric field, in magnetic field, and then in electric and magnetic field. So you will see in electric field, in the direction of field, charged particle will move in a straight line. Perpendicular to E, path will be parabolic. In magnetic field, perpendicular to B, it will move on circular path. When it enters in the direction making an angle theta with B, you will get helical path. And when E and B, they are perpendicular and charged particle is released, it will follow cycloidal path. So we will talk about these paths in motion of charged particle in electric and magnetic field. Now we will see second part is magnetostatics. What topics we are going to study in magnetostatics? So second part is magnetostatics. So in magnetostatics, we will talk about magnetic field due to steady current. We will talk about steady current. Magnetic field due to steady current. So in magnetostatics, you will see source is a steady current. In general, we will represent it by current density J. So call it as steady current. So if you have current, steady current, you can find magnetic field B. And in this field, we will define vector potential A. In electrostatics, we will define electrostatic potential. But in magnetostatics, we will define magnetic vector potential. So again, when current density is given, how to find magnetic field? Or when current density is given, how to find vector potential? B is given, how to find J? A is given, how to find J? A is given, how to find B? And B is given, how to find A. if you know these relationship, you know about magnetostatics. For given steady current distribution, how to find B and A, then you have to relate these parameters. That is all about magnetostatics. Is it clear? So
Yes.
in magnetostatics, we will first see what is the condition for a steady current. So we will talk about continuity equation. So first we will discuss continuity equation. That will be the general continuity equation. In motion of charge particle, you will see when a charge particle moves in an external magnetic field, it will experience magnetic force. And you know that in a wire, you have a current when charge is in motion. So when a current distribution is placed in an external magnetic field, what will happen? These moving charges will also experience magnetic force, or you can say this current element will experience magnetic force. So we will also talk about magnetic force experienced by current element in an external field. So we will discuss magnetic field, magnetic force experienced by current element in an external magnetic field. And then we will see if steady current is given, how to find magnetic field. So you know that we can find magnetic field using Biot-Savart law. Biot-Savart law and superposition principle. You will see in vector addition, we will talk about superposition because E and B, they are the vector quantities. So using Biot-Savart law, again, in certain symmetry, you can find magnetic field. Sometimes symmetrical current distribution is given. For example, that symmetry will be, you have infinite wire, infinite sheet, or solenoidal, ideal solenoid. In that case, we can use Ampere's law. So Ampere's law and its applications. Ampere's law and its applications. Then we will talk about magnetic vector potential. Magnetic vector potential. We will also talk about magnetic dipoles. Magnetic dipoles. Then we will talk about magnetization. Magnetization vector M. You will see when a magnetic material is placed in an external magnetic field, it gets magnetized. And we will talk about bound currents. In polarization, we will discuss bound charge. In magnetization, we will talk about concept of bound charges. Concept of bound current, not charges. Concept of bound current. Again, when you have a magnetized material and you have to find magnetic field, then we will discuss Ampere's law. In presence of Ampere's law, in presence of magnetized material. Ampere's law in presence of magnetized material. You will see in Biot-Savart law and in Ampere's law, we will talk about magnetic field in terms of B vector. But here we will talk about magnetic field in terms of H vector, that is B by mu. And then we will see magnetostatic boundary condition. Magnetostatic boundary conditions. This is in terms of B, H and vector potential A. So we have to focus on these topics in magnetostatics. Is it clear? So please note down. Please note down these topics in magnetostatics. Can I continue?
Yes, sir.
Yes, sir.
So now we will see third topic. So third topic is time varying field. So initially it was assumed that electrostatics and magnetostatics, they were separate subjects. But later Faraday has shows that a changing magnetic field creates electric field. And then Ampere has modified his own equation. And he showed that a changing electric field also creates magnetic field B. So time varying B and E creates each other. And then Maxwell has combined all these equations in terms of famous Maxwell's equation. So in time varying field, we will start with Maxwell's equation. So third is time varying fields. Now you will see source is function of time. For example, charge density is function of distance as well as time. And current density J is also function of R and T. So corresponding E and B is also function of R and T. If you have a static case, you will see rho is function of R independent of time, and E is function of R and B is function of R. These are the static case. This is the static case. And this is the time varying case. So we will first talk about Maxwell's equations. 4 Maxwell's equations. And in this we will mainly discuss, you have 4 equations, but we will talk about Faraday's law, and modified Ampere's law. You will see first two equations are same that we will discuss in static case. So we will get two new equation, one from Faraday's law and another from modified Ampere's law. So we will talk about Maxwell's equation, general Maxwell's equation, and inside matter. Inside matter. So we will start with Maxwell's equation. We will also see what will be boundary condition for time varying field. Boundary conditions for time varying fields. We will discuss boundary condition for static field and also for time varying field. And then we will talk about electromagnetic waves. Electromagnetic waves. In short, we call it as EM waves. EM waves. So we will see EM waves in free space, in dielectrics, and in conductors. And we will also see EM waves in a rectangular waveguide. In a rectangular waveguide. So this will be unbounded media, and this will be the bounded media where boundary is fixed. ठीक है? Then we will talk about reflection and transmission at an interface. Reflection and transmission at an interface. So we will talk about normal incidence and oblique incidence. Normal and oblique incidence. When it strikes normal to the interface and when it strikes at an angle. So we will see behavior of EM wave after reflection and transmission. We will calculate reflection and transmission coefficient also. Then we will talk about potential formulation, potential formulation for time varying fields. We will define scalar and vector potential for time varying field. And in this, we will talk about Coulomb and Lorentz gauge condition, We will also talk about gaze transformation. Gaze transformation. Then we will discuss concept of retarded potential. And lastly, we will discuss radiation from moving charges. Radiation from moving charges. So I will focus on these topics. You have two other topics. One is optics. In optics, you have to just see basics of interference, diffraction, and polarization. Interference, diffraction, and polarization. So this topic will be discussed by Sajal sir. Optics will be discussed by Sajal sir. I will discuss up to radiation from moving charges. And you have another topic that is related with special theory of relativity, that is relativistic electrodynamics. And this topic will be discussed by Atul sir. So that will complete the whole syllabus. Is it clear? Please note down. So any doubt in syllabus, what you are going to study? Is it clear to everyone?
Yes, sir.
Yes, sir.
Sir, the pointing vector theorem is come in which slide?
That we will discuss in EM waves. There are I told you these are the main topics. There are subtopics in each topic. So that we will discuss.
Okay, sir.
Sir, EM induction is not there.
That I will discuss when I will talk about Faraday's law. That is electromagnetic induction.
Okay, sir.
Everything is there. There are subtopics. I have not written subtopics. These are the main topics. Complete syllabus will be covered. So don't worry. Now, what should be your approach of learning, or how I will proceed? So, our approach of learning. So, first step should be you have to develop conceptual understanding of each topic. Conceptual understanding of each topic. Then you will learn problem solving techniques. so that you can solve problem quickly and easily. You can solve problem quickly and easily. You can solve problem quickly and easily. And then you need lots of practice to build speed and accuracy. So you have to build speed and accuracy. So we will follow these steps. Now, most important thing is what should be your source of study. This is very important and you have to stick to it. So most important thing for you is number 1. So what will be the number 1 source of study for you?
Class notes.
Notes.
Class notes. Good. So you have to follow class notes. You have to revise your class notes regularly. And then you need practice. And for practice, we will provide you assignments. So you will get assignment and you have booklet questions also. This is for practice. Then you have to appear in weekly class test. You have to check yourself regularly. So in each week, you will get class test so that you can test yourself. How is your preparation going on and where you stand? And then you will also solve previous year questions. So we will provide you topic wise previous year questions. Topic wise previous year questions. So you have to practice those questions. And lastly, you have to appear in our test series. You have to give final touch to your preparation when you join our test series. In test series, you will get part test. So there will be 9 part tests topic wise plus 1 test on general aptitude. So you will get 9 plus 1. This 1 is for general aptitude and 9 topic for physics. And you will get 5 full length test. We will provide this for NET and GATE. NET and GATE exam. We will provide you solution for other exam also. For test series, you can join NET and GATE. Is it clear?
But topic of previous year.
For each topic, you will get NET as well as GATE. For example, electromagnetic theory, you will get on exact pattern only questions on electromagnetic theory. Similarly, for other topics. Your voice is not clear.
Sir, previous year.
We will provide topic wise. For example, in electromagnetic theory, we have arranged it in Coulomb's law, Gauss law, potential in same order that I have discussed. So that you can easily check when you have studied Coulomb's law, you can solve questions on Coulomb's law. Gauss law, you can solve on Gauss law. So we have arranged this topic wise. ठीक है?
Sir, where we will get, sir, previous year Google Classroom, sir?
Google Classroom, we will provide you on Google Classroom. Now, what is the reference book that you will follow? So, if you have time, then you can follow this book, Introduction to Electrodynamics by David J. Griffith. Is it clear?
Yes, sir.
If you have time, then you can go through Griffith also. But I will advise you, for each topic, don't give you more than 1 hour. For, you can say, for 1 hour of video lecture, don't give more than 1 hour on book. In that 1 hour, if you get some additional point, improve your notes. Otherwise, it is difficult to read complete book. In 6 months, you have to study your class notes for each topic. So you don't have much time to give on book, but at least you can give for 1 hour of video lecture, you can give 1 hour on book. And if you find some additional point, please update your notes. Is it clear? So if you have any doubt in this, you can ask.
सर जनरल एप्टीट्यूड का भी कुछ कराएंगे क्या आप लोग?
You will get classes on general aptitude also in month of November.
ओके, थैंक यू सर.
सर क्लास टेस्ट कैसे होंगे, ऑनलाइन प्लेटफॉर्म पे या आप क्वेश्चन प्रोवाइड करेंगे?
Google Classroom, when you have joined 5th August batch.
Yes, yes.
Other students have appeared on Sunday. They will give test for each topic. For example, in electrostatics, I will take 2 or 3 tests. So weekly you will get 1 test.
Okay.
ठीक है?
Sir, what will be the marking pattern for EMT?
In our test,
No, sir. In the net exam. Like 5 marks, 3 marks, or 1 mark.
okay. Approximately you will see 8, on an average, you will see 8 to 9 questions you will get in net exams. So 3 to 4 questions in 3.5 marks, or you can say 3 to 4, or let's say 4 to 5 questions in 3.5, and then rest 3 to 4 questions on 5 marks. This is 3.5 marks and this is 5 marks. So approximately you will get 8 to 9 questions. You will get 8 to 9 questions from electromagnetic theory, this part.
Gate also same.
50%. In gate also you have approximately 9 to 10 question also.
Okay, sir. Okay, sir.
We will give you separate seat.
Sir,
We will give you separate seat for gate and net previous 5 to 6 years, in which you will get how many number of questions they have asked.
okay, sir. Okay.
So that we will provide you separately. Even on our website it is given. On our website we have given it previous year pattern analysis. You can also download it. Any other doubt?
So when will we have about test series?
Test series, our final test series.
Yes, yes, sir.
Full length test series you will appear in November, and part test we will start in October. When one topic is completed, you will get part test also.
So what about preparation of JEST? Because JEST has some more conceptual questions.
No, we will give you solution of JEST also. And we will cover the whole syllabus. Same class notes you have to study for JEST exam also. and previous year paper you will solve separately.
Okay, sir.
Because topic is
Sir,
same.
ये
If it is
जो online
test,
सर
test
ऑनलाइन
series
जो
final
टेस्ट होगा
will be
क्लास
on-
टेस्ट,
हाँ। अभी जो
तो
क्लास
क्लास
टेस्ट
टेस्ट
लेंगे
का वो
उसमें
असाइनमेंट के गूगल क्लासरूम में सबमिट।
गूगल क्लासरूम में ही आपको टाइम दिया जाएगा, उस टाइम में आपको अपियर होना होगा। जो पुराने बैच के स्टूडेंट हैं
Okay,
उन्हें
sir.
आइडिया है कि वो वीकली टेस्ट दे रहा है। जो 5 अगस्त के होंगे शायद अभी उनका टेस्ट नहीं हुआ होगा।
हाँ सर, मैं 5 अगस्त पे हूँ।
हाँ, तो इसीलिए अब नेक्स्ट वीक से आपका भी प्लान होगा टेस्ट का, ठीक है?
सर एग्जाम
ठीक है,
पॉइंट
सर।
ऑफ व्यू टेक्स्ट बुक प्रिपेयर करना जरूरी है?
दैट डिपेंड्स ऑन यू। क्लास नोट्स इज सफिशिएंट, बट कई बार होता है स्टूडेंट्स को कि कॉन्फिडेंस बिल्डअप के लिए आप एक बार गो थ्रू हो सकते हो, बट टाइम वेस्ट नहीं करना है। मैंने क्या बोला कि अगर मैंने कूलम्स लॉ डिस्कस किया तो आप 1 घंटे में जो भी बुक से पढ़ सकते हो वो पढ़ के अपने नोट्स इंप्रूव कर लो बस। अदरवाइज फिर उसका कोई एंड नहीं है। मैं भी आज भी सेम बुक पढ़ता हूं। तो अगर एग्जाम क्वालिफाई करना है तो आपको प्रॉपर मैनेज करना होगा, ठीक है?
ओके।
So in next class, I will start with first topic, that is Coulomb's law. Thank you.
Okay, sir.
Okay, sir. Thank you. Okay.
Thank you.
Thank you, sir.